Hi, Nine. I just wanted to make you a really quick video for your warm-up session. It is going to be very quick because I know you only have half an hour, but just of a few key things you need to remember for your assessment. So the first thing is being able to draw horizontal, vertical, and the basic diagonal lines on a graph. So remember that if it is horizontal, it is crossing this is y, this is x, it is crossing the y-axis. So if I have this horizontal line, it's crossing the y-axis. So it's always y equals whatever number it is crossing on the y-axis. So in this case, it is crossing at 6. So the horizontal line that I have just drawn on the graph is y equals 6. It's crossing the y-axis, it's crossing at 6. So every coordinate on that line has a y value of 6. They're all like 1, 6, 8, 6, negative 9, 6, all of the points on that line. If it is a vertical line, so let's change colour. So vertical is crossing the x-axis. So there's an example that is crossing the x-axis and it is crossing at -7. So that has the equation x equals -7 because it is crossing the x-axis at -7. All of the x values on that line have an x coordinate of -7. So they're all -7, 1, -7, 9, -7, -8, and so on. All of the points on that line have an x value of -7. And then you have your diagonal lines. So let's choose green maybe. And your basic ones have gradients of 1 and go right through the center of the graph. So I'm drawing it really slowly because I'm trying to make sure it goes through all the correct points, but it looks something like that. That is your positive line. So this is y equals x. And then if we had the same line but going in a negative direction, so like that, and going the other way like this. Here we go. It's taking me just to draw it. There we go. This would be y equals -x. Okay, so two diagonal lines depending on which way they're going. They're either y equals x or y equals -x. Remember, positive lines go this way, so start low and go up, and negative lines go the other way. These lines are not even close to being straight, but hopefully you get my drift. So yeah, positive start low on the graph and go up, negative start high and go low. Yeah, so there's a very quick whistle stop to it of horizontal, vertical, and your real basic diagonal lines. Let's move on. We need to be able to identify which equations would have a certain solution. So this time we're using x equals 3. In order to do, I've put x and then a, a equals 3, not x. What we need to do is use a bit of substitution. That's the easiest way to do this. And take a equals 3 and replace it with, so replace the a in the equation we've been given with 3, and then check and see if we get 9, because that's our equations are all equal to 9. So the first one, we've got 4a. So that, remember when we have 4a, it means we're multiplying. So that is 4 multiplied by a is now 3. And then we're going to subtract 3 from that answer. So 4 times 3 is 12, minus 3 is 9. So A is a solution of this equation. We can circle that one, because when we put A into the left-hand side, we get the same answer as they've given us on the right-hand side, which is 9. If we do it with the next one, so we've got 3 minus 4 times A, so 4 times 3 again, then we've got, that is equal to 3 minus 4 times 3 is 12. So 3 minus 12 is minus 9, which is not what we were given, which is 9. So this one, we can't circle that one. 3 is not a solution of that equation. We can then repeat that with the rest of the equation. So the next one, we've got minus 3 plus 4 times 3. So that's minus 3 plus 12, which does actually give us 9. Okay, remember you can use a calculator for your assessment. -3 plus 12 is 9. So we can circle this one. A is a solution. And then the last one, we've got 4a, so 4 times 3 again, plus 3 this time is equal to 4 times 3 is 12, plus 3, which gives us 15. So this one, again, a equals 3 is not a solution. I know I'm going through this really quickly. Obviously, you can watch this as many times as you have time to in the warm-up session, but I just don't want this video to be too long. But that's all you do. Replace the a or the x or whatever it is with the value you've been given, work it out and check if your left-hand side is equal to your right-hand side. Next, solving an equation where we have x on both sides. There's lots of equations on your assessment. These are the most difficult. Obviously, you can get the more simple ones where you only have to do 1 step or 2 step. But the key thing to remember is that we always do the opposite of whatever is there. If we have, again, I wrote x and a. This should be x as well. So let's pretend it is. If you have your variable, your x, your letter, whatever that letter may be, on both sides of the equation, then we have to get them all on one side first before we can start to solve it. So to do that, I'm going to take the smallest amount of x, which is the 6. We've got 6x and 11x. 6 is less than 11. And we subtract it from both sides. So when we have 6x minus 6x here, they cancel each other out, leaving us just with the 29 there. On the other side, we've got 11x take away 6x, which gives us 5x. We've still got the plus 4. Now we can deal with the plus 4. Again, remembering we do the opposite. So we have to take 4 away because minus and 4 is the opposite of add and 4. So take 4 away from both sides, leaves us with, again, that's going to cancel out, leaving us with just the 5a. 29 minus 4 is 25. And then we finish that off by getting rid of the 5. 5 is, right now, is multiplying the a. The opposite of multiplying by 5 is dividing by 5. So we divide by 5 on both sides. 5a divided by 5 leaves us with just a, which is what we want. I've changed back to a. Ignore the fact that I keep changing the letter every time I write it down. Imagine it's all x. Let's just put it back to x. 5x. So yeah, 5x divided by 5 is just x, 1x, and then 25 divided by 5 is 5. So x is equal to 5. That is always what you are looking for when you are solving something. You are trying to get the letter on its own with nothing else connected to it. Okay. Solve an inequality this time. Exactly the same method as an equation, but it has a different sign in it. And that's all you have to remember when you're doing this. Because it's got a bracket in, we have to remember to multiply the bracket out first. So 4 times x is 4x. Don't forget to multiply the number part as well. Okay, this is where people make a little bit of mistakes. So we have to remember to multiply both things inside the bracket by what's on the outside. 4 times 2 is 8, so we have 4x plus 8. We still have is greater than or equal to 24. Now we can start solving it. So we're going to minus 8 from both sides, which is the opposite of adding 8. They cancel out, leaving us with just the 4x. 24 minus 8 is 16. Now we're going to get rid of the 4 by dividing it. 4x divided by 4 leaves us with just x. Is greater than or equal to 16 divided by 4 is 4. X is equal to 4. Okay, again, the only thing that's different is the sign. It's not equals to, it's greater than or equal to. More on inequalities there. So once you've got your solution, you sometimes ask to find values that actually work for that solution. Because when we're finding an inequality, we're actually finding a range of values, not just one number. So anything that is bigger than 4 or bigger than or equal to 4 would satisfy this equation. So any of the numbers in this list that are equal to 4 or bigger than 4 would satisfy this inequality. So all of these numbers would satisfy. Anything less than 4 doesn't. That's it. That's literally it. That was a very quick one. I'm going to keep going. I'm, again, very aware of trying to keep this short. Show that questions. So they've given you an answer, a question and an answer here. you are showing that those two things are equal to each other. Don't be put off by this sign. You're just showing that they're the same. So what we need to do here is expand these brackets, simplify the equation, and we hopefully should get 2x plus 13 if we've done it right. So expand the bracket first. 5 times x is 5x. 5 times 2 is 10. Now the thing to be careful of here is we are multiplying minus 3. That 3 is negative, so we cannot forget that when we are expanding the bracket. So minus 3 times x is minus 3x, and then minus 3 times minus 1, a negative times a negative makes a positive. So that becomes plus 3 times 1 is 3. Now we can simplify that, so wherever we have common terms or like terms, we can collect them together. So we have x here and we have x there. 5x minus 3x, remember the sign always comes in front of the term, so this minus is attached to the 3x, not the 10. 5x minus 3x is 2x, and then we have 10 plus 3 is 13. So there we go, we have shown it because it is the same as what they gave us in the question. We end up with 2x plus 13. That's all you have to do. So all we've done there is expanded the brackets and shown how we did that, and then we've collected the terms to show that we do end up with 2x plus 13. Okay, next one, making x the subject, very similar to our equations, except we are going to end up with more algebra as our answer instead of a number. We're making x the subject, so anything that has happened to x, any operation that has happened to x, we have to undo, we have to reverse. So we're going to start with that plus y, and we're going to minus it from both sides first. Gives us plus y minus y cancel each other out, makes nothing. So we have 7x and then 2z minus y. We can't simplify that at all. We can't really do much with that other than just write it down. 2z minus y. We don't know what z is, we don't know what y is, so we can't subtract it and get a value. We can't put it together. All we can do is write 2z minus y. And then same as we did before, we need to get rid of the 7 by dividing it. So divide 7 on both sides. Gives us x, because 7x divided by 7 is 1x, or just x. And then again, on the other side of the equation, there's nothing we can do to simplify it, so all we can do is pop in a fraction, and it becomes 2z minus y. That's it done. That's our answer. So the only thing that's different is that our answer still has algebra in it. We're not getting a number like when we solve an equation. We're getting another algebraic expression as your answer. How much further have we got? There's only 2 more questions, okay? This one, we need to be able to identify a y-intercept from a graph and work out the gradient, which is the one that we always get a bit confused with. So y-intercept is literally just where it's crossing the y-axis. Write the coordinate if you can. So the x part is 0 and it's crossing at 2, so the coordinate is 0, 2. That's it. Y-intercept done. That's an easy 1 mark. Gradient is a bit trickier. I shouldn't really have circled that, but never mind, I've done it anyway. The best thing to do is pick 2 coordinates on the graph and you draw in the triangle, because I'm going to pick 2 down here so it's out of the way of that circle that I've just drawn. So I'm going to pick these 2 points. I'm going to draw my triangle to join it up. My triangle has a height of 1, 2, 3, 4 and a length, a base of 1, 2. And to find the gradient, I do the height, so the y, divided by the base. So we're doing up, so the up part divided by the across part. So that is 4 divided by 2, which is just 2. So the gradient of that line is 2. One more thing you could be asked to do with that is then put it into the equation of a line. So it's always y equals mx plus c, where m is your gradient and c is your y-intercept. So using what we found from this line, this equation would be y equals 2x, because our gradient is 2, plus 2 because it crosses the y-axis at 2 as well. That would be it. That's all you have to do to find the equation of the line. Remember that you can also use that to match up equations with the lines themselves. Last question, calculate the surface area of a cube. This is a cube, that should be 4 centimetres as well, because all of the lengths are the same. So I know it doesn't look like it, it's a terrible drawing of a cube, it's very wonky, but it is. To find the surface area, find the area of each square face, and then because it's a cube, all of the sides are exactly the same, so we can just multiply by 6 because there are 6 faces on a cube. So the area of one of the squares is 4 times 4, which makes 16. That is centimetres squared because we're talking about area. And then to work out the total surface area, we can do 16 multiplied by 6. Now, don't have a calculator. 10 times 6 is 60, 6 times is 96. So that gives us a total surface area of 96 centimetres squared. And that's all you have to do for surface area. Find the area of one face, multiply it by 6. And that's it. Very, very quick. Hopefully that helps though and gives you a few pointers before you start the assessment next lesson. Good luck. Yeah, I'm sure you're going to do great. Thanks for listening. Thanks for watching. Hope it helps. Have a great day. Bye.